So question number 7 says our 4-point charges each equal to Q equal to 4 microcoulombs are held at a corners of a square. So let's draw a square over here. So this is our square, let's say, okay, and corners of this square 4 microcoulomb. Let me place here 4 microcoulomb, 4 microcoulomb, and 4 microcoulomb, and 4 microcoulomb over here, and each side is 10 centimeter as per the question. Okay, find the magnitude and the sign of a charge, magnitude and the sign of the charge Q, which is to be placed at the center of the square. Okay, you are placing a charge over here Q, okay, center of the, okay, so that the system remains in equilibrium. So this is just an extended version of the previous type which we have done, where we had 2 charges and we used to place the third one, right? Okay, now here we are finding the force, okay, the resultant here. So you can choose, since you can see that all of them are 4 microcoulomb, right? So it's your wish if you want to find the resultant on A, B, C, D. Doesn't make any difference because all of them are there. They are influenced equally by this Q. So what is the core concept here? The net force acting due to all other charges on A, let's say, let's start with A only, will be equal to the force acting between A and this O. Let me repeat again. The force acting between AB, AC, AD must be equal to the force of AO. If they are equal, then the resultant will be in equilibrium. Clear? So first of all, let's see what are the forces acting on A due to B. So that is a repulsive force acting in this direction. I am writing here force on A due to B. Force on A due to C, that will be acting in this direction because this is the line joining the two. Force acting on A due to C. And force acting on A due to D, that will be in this direction, FAD. Now what's the angle between FAB and FAD? 90 degrees. So first of all, let me find the magnitudes of these, okay, so that we can use the resultant formula. So force on A due to B, that will be equals to K. Both charges are same, so I will put the values at the end. So K, Q1, Q2, Q square upon separation. Separation, all of them are similar. So separation is A square, okay, where A I am taking it as 10 centimeter. Similarly, what's the force on A due to D? K, separation same and charges are same, so A square. Two forces acting at what angle? Theta is 90 degree. So what will be the resultant? Resultant of these two. Which two? These two forces. We have not considered FAC yet, so be careful. So resultant of these two will be root under A square plus B square plus 2AB cos theta. This is from class 11th, okay, resultant of two forces. But here A is equal to B. So if A is equal to B, let me substitute A as FAB and B is also FAB. Why FAB? Because FAB and FAD are same, right? We can see it on the screen. What is angle theta? So theta is 90 degree between FAB, which is here, this is one force, and another force is over here. So both are 90 degree apart. So what is cos 90? 0. So no need of writing the last term. Okay, so let me keep it up till here. Now this will give me what? This will give me, if both are same, so this will be FAD instead of FAD. Let me write it here, FAB only, same it is. So this will be root under 2 FAB, 1 apple plus 1 apple, 2 apples, and root and square will go, so it will be root 2 FAB. FAB is what? KQ square by A square. I hope this is clear. Now this is the force where it is acting. This is the force which will act along this direction. Okay, let me remind you from 11th standard, if one vector in this direction, another vector is in this direction, the resultant will be in this direction, right? So this will be our resultant, in this case R. Be very careful, this is not the net force acting on A. This is the force due to B and D. So this R is along AC. Can we add both of them? Yes. Directly? Yes. Because theta is 0 degree between them, so you can directly add them. So net force acting on A, now we will get it. That will be R plus force due to C. R is how much? Root 2 KQ square by A square, and FAC. Now what's the separation between AC? AC square. AC is what? This gap is AC. So this gap is nothing but root 2 times A. So from where you got this relation? 10th standard. Okay, you can use diagonal this ABC as a right angle triangle. Use Pythagoras theorem. Take it as A, take it as B, A. Both are A, so that will be root 2A, right? Okay, great. So try this yourself, how to find the length of the side AC. So this will be force FAC K, charge on A Q, charge on C also Q, upon separation root 2A whole square. So this will be, let's take common here. Let me just scroll down and take common here. So this will be KQ square by A square, and here you left with root 2 plus 1 by 2. Correct? This is the net force acting on A. Now the question, let's read the question. Okay, you can choose even B, C, anyone. Okay, so the question says, find the magnitude and the sign of the charge on Q, charge Q, which placed at the center of the square so that the system of the charge is in equilibrium. Now these FA is the net force acting due to B, C and D. This must be equalized by the force acting between A and the center. What is A? A here is K. Let me write here Q. Capital Q is the charge at the center. And what's the gap? If this is root 2A, what's the gap between A and O? Root 2A by 2. Look at the diagram. This is root 2A by 2. So let me keep it here, root 2A by 2 whole square. Let's simplify this to get the value of capital Q. So this will be our, here K cancels with K, Q cancels with one of the Q, and this will be left with Q upon a 2A square by 4, and that is 1 by A square 2 root 2 plus 1 by 2. Let's cancel this A square with A square, and taking 2 by 4, which is 1 by 2 on the other side, it will be Q equal to 1 by 2 root 2 into 2 plus 1 by 2. Clear? And this, on solving further, okay, will give us, let's see how much. So this will be 2 2s of 4. Okay, so it will be 2 root 2 plus 1 by 4. So this, okay, this will be our charge at the center. Okay, but there is one Q more left which I missed at this point. We cancelled only one with Q. So let's place it here again. A small Q is left, right? There is a Q square on the right hand side. So into 2 here, into Q here. So substituting the value of Q, what's our Q? Let's scroll up, and this is 4 microcoulombs. So let me place here, it will be 2 root 2 plus 1 upon 4 into 4 microcoulombs, that is 10 to the power minus 6, 4 cancels. So our final result is, what is the net charge? It will be Q equals to 2 root 2. All are positive charges? Yes. So what should be the magnitude of this, sorry, charge of this? Polarity negative. So minus 2 root 2 plus 1 microcoulomb. So that is option A in this.